Hello and welcome once again to episode 92 of Code Completion. We are a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist Spencer.
Hey there.
So almost any app developer will have to think about storage one day, and this can be storage for like the library that your app manages or maybe individual document formats, but there's so many options to choose from. I heard that recently you had a conversation with your students about this, correct?
Okay, so like the context for this is, my students are brand new to iOS development. They've been doing it for a few months and stuff in kind of a learning setting. And so they probably don't know all of the, or many of the storage mediums that are available. But what the conversation ended up being was kind of going over, I'd say, two or three of like the most basic, or rather, I guess common, I shouldn't say basic, storage solutions, and saying, what is the best fit for them. And I can't quite remember exactly what their group project was, but it was storing a relatively small amount of information, like an array of some structs of like 4 or 5 properties. There wasn't much information being stored there, and they were only loading it up on launch of the app and when they wanted to sort of finish. I think it was like a quiz type thing, and so they were saving a bunch of questions that they had already answered and ones that they still had to answer so they could pick up where they left off, I think is more or less what it was. But it wasn't, there was no object relation database needing to be created or anything. And so the conversation ended up going where they started looking into storage solutions themselves. I think it was them that just were like, oh, I should use CoreData, or yeah, I think it was CoreData. And so they started going on that, and they realized, that what a beast CoreData is, especially to learn. It's not necessarily the most straightforward thing. But eventually I got talking to them and I was like, well, honestly, for what you're doing, one, the information isn't, sensitive in any way, so there's no issue there. But also, it's not a bunch of information. You're going to be saving very, very small files in whatever, very small amounts of information, whatever format it is. So I was like, okay, well, let's step back. Let's not have you get overwhelmed by CoreData, because that's that's a lot, especially for someone new. And again, it was like they would have had one table or one. Now I forget what the name is. I'm thinking of like Postgres. One model in CoreData, and that's it. There were no relationships or anything sort of complex in that way. So we eventually started talking about Codable and gave them a couple articles on saving, like a plist or JSON, and saying this is probably what you're going to want because of just one, the sheer easy setup of conforming your objects to Codable, and then saying, hey, JSON encoder, encode this, JSON decoder, decode this, and you're good. So that kind of sparked this whole thing where we wanted to go over storage mediums, because there are a lot, and sometimes it's hard to choose the right one for you. And am I saying that was maybe the best choice? I don't know. If they were making a more complex app later on, maybe it would have been nice to have the thing in CoreData to begin with. So I thought it would be good to kind of, hash all of this out and see what you thought as well. So anyway, yeah.
Yeah, I think that's interesting, because perhaps my first gut, like if I did not know what I knew, like what I would reach for first was not even like CoreData or Codable or anything. It's just stick it in user defaults. That's like one of the first things you tend to learn about, and it's like the easiest of APIs to use. It's really not difficult by any means. So it's something that's very easy to grasp towards, even though it's oftentimes the wrong solution for so many things. So maybe something good that we can start with is locations for storage. And I can enumerate a few of them. We can go over them. For instance, you can put stuff in the user defaults directly, or you can choose to write a file to the documents folder with FileManager, or to a cache folder, or you might have some sensitive data, so you might want to choose to save that in the keychain. Or finally, you might want to have this data sync across multiple devices with putting, once again, relatively little effort into it. So you might want to use the iCloud key value store, which is kind of like user defaults except shared. So those are all different areas that we can go ahead and put things in. But it really depends on what those things are. So do you have like a good grasp as far as like which one your students should probably have leaned towards?
Yeah, I mean, so I did think about user defaults, and my only thing with that is what both I and previous students that I had, especially at the first boot camp I worked at, was they would sort of, I don't know about abuse, but maybe rely on user defaults as a crutch too much, where when they did start to build more complex apps, then that was the only thing that they knew. And so my thinking with Codable was like, I don't know, adding a couple properties, optional properties to a struct is pretty easy, and still having the whole Codable thing work, but it's a little more scalable, I think, than user defaults. But I guess that was my thinking on not using user defaults. It was like, I guess, a good middle ground in between like too easy and perhaps not like hyper scalable, to CoreData being like probably too much for their use case, if that makes sense.
I would also consider like user default, if you're writing a production app, is something that you should not store anything very important in, because like as a first way of debugging a problem, nuking the user defaults might be a solution to try.
That's true.
And I'm always hesitant to this because I know that not every app developer follows this religiously, that the user defaults hopefully doesn't have anything super important in it for the app to like continue working the way it was working. It's not just like, oh, I wanted to put my window here, or oh, I wanted my panel to show up on this side of the screen, kind of thing. And people tend to put way more in there just because it's simple, right? It's very straightforward to do.
Yeah, I mean, that's the whole thing, right? They're user defaults. They're like user settings, basically. And so, like, I'll almost always try to, especially with students, gravitate towards, or rather, like, push them away from using user defaults for anything other than, like, just straight up settings. And like you said, anything that's not mission critical, like a theme or whatever, cool. Yeah, throw that in. But, so, I don't know.
Yeah, and if you're using SwiftUI, you might know this under the term app storage or scene storage. It's still in the user defaults at the end of the day. So I would like definitely keep that to settings that the user prefers, like preferences. But do not necessarily keep pertinent information there, especially not things like usernames and passwords. Like you might keep the last account someone had open in there, but you might not want to keep the account information in there, kind of thing.
Yeah, for sure.
I guess that leads into the keychain. So the keychain is an excellent place to put usernames and passwords, but it's a poor place to put lots of data. Like oftentimes, a strategy that you might want to take is, if you have lots of data you want to keep secure, to store the key to encrypt or decrypt that information in the keychain, but then store that information as in its encrypted form on the disk in like the FileManager. That's oftentimes a better trade-off. Oftentimes people think that the secure enclave is like storing all these keys that the user's keeping. No, it's just storing like a master key that can unlock the keys that are in the user's keychain. And that's how it actually works. It's not really storing any information on behalf of the user. It's just storing the key that can unlock that information. And it never leaves that device, meaning that information is passed to the secure enclave and it's encrypted and passed back. So usually it's a set of it's a chain of keys along the way, and you can think of the keychain as the same thing for your data. It's just where you want to store the keys, hence the keychain. and then you can go ahead and store that like encrypted bulk information somewhere else, like even in the user defaults at this point, if you're feeling extra lazy about it. But you probably want to store it in a file as well, right?
Yeah, for sure. So like you said, with storing things in FileManager, it's I mean, the easiest way that I like to think about FileManager is really just like a programmatic finder. You can do pretty much any operation that you want, copy, move, all that stuff. So it's just accessing your your phone or your device's file system. So you can store whatever you want in there. I mean, oftentimes, like if you're using CoreData, maybe you store images in there and just have like the file name stored in CoreData, but the image itself is stored in some folder or whatever. But with that, you've got like we were talking about, you could just have a JSON file that is using Codable. You could use XML. You could use plist. You can store anything you want in there. And so that's ultimately, that's, like I said, that solution that I had the student kind of end up going with. And I think it worked out okay. They've moved past their group projects, and I'm only there once a week, so I don't quite know the end result of that. Maybe I'll ask him and do a follow-up. But that can be nice because, you can just store whatever you want in there in any format you want, whether it's something common like JSON, XML, or whatever. But you could also, if you really wanted to, you could store anything you want. You could store your own binaries in there, which is way beyond my pay grade. I've never done that. But in theory, you could have your own, file type and encrypt that however you want, and just store that on your device's file system.
The only thing to keep in mind when you are storing to the file system is where you are storing it. Like Documents is a great place to do it because it is backed up. It is kind of hidden from the user in most contexts, so that's a good default place. There are some special folders that quote unquote iTunes used to be able to access, which is the Finder now on the Mac. So if you plug in your device to a Mac, you can go ahead and use that as a place to swap files easily. And then there are other folders like caches, which can be used to store lots of information that you might need, but that information might not be 100% necessary for your app to function. And what this means is the device can go ahead and clear it when your app is not running, to make more room for the user's actual data. So if there is anything that you can always rebuild at any moment in time, like caches is an excellent place for that.
So with that, I know that there's like the NS temporary directory. Would that count as a cache, or would that be something different?
So that would count as like a very short-lived cache. So usually device reboot will clear that. Or you should ideally clear that when you're done, like doing whatever you're doing. You just needed a space to write a file. That's generally what that's for. So if you find yourself writing to the temporary directory and then not cleaning up afterwards, it's kind of a bit smelly in terms of practice. Because you are essentially littering the user's device with stuff, and the system won't know if it can clean it up yet. It will clean it up eventually, but it doesn't know if it can clean it up yet. If your app is still technically open, it can't just go ahead and say, okay, it's time to clean this, because you are still potentially editing those files. So definitely, if you are writing to the temporary directory, do go ahead and delete those files when you're done with them, or move them out of the temporary directory to where you actually want them to live. And that would be what's considered best practice for that.
Okay. So for the caches, I've never actually used kind of a specific directory as a cache. So do you is it like one of the search path directories where if you're saying like URLs for directory, and you say instead of documents, you say
caches.
It's just caches? Oh, sweet.
Yeah, it's a built-in,
in the library somewhere?
Yeah. So it's a little different on the Mac versus iOS. So on the Mac, you have your home directory, and then in there you have a library directory, and then in there you have all sorts of things, like caches is one of the things that are in there. User defaults are under preferences, for instance. On iOS, every app is given a little like partition of the operating system, if you will, and it's as if it's its own home directory right then and there. So you have documents, but you also have a library caches, and the OS stores some stuff in there on your behalf. So for instance, when you close out an app, it takes a snapshot at the last moment, so that way when you launch the app, it shows something that's stored in your library caches. You can look it up. Like it's right there next to your other files. So do poke around at that, especially with the simulator. You can print out the path that you just wrote to, and then you can just open that in the Finder and see exactly like what's being saved with your app. It's definitely an interesting little bit of investigation that you can do, because you can learn about how the OS versions are like differing over time, and see what they are doing and how you can learn from that, right?
Yeah, that's cool. So, okay, continuing with like the difference between the temporary directory and the caches. So you said the temporary directory, it'll get cleared sometime, but kind of bad practice to just let it go. With the caches, does it clear itself like on exit of the app? Like, is it basically just like RAM, or like does it? Yeah, I guess when does it clear itself, or do you have to still clear it?
So ideally, you would only clear it when you don't need that data anymore, but you saved it to the caches because you might need it later, right? So it's not going to be cleared when your app exits or when the phone reboots. It will only ever be cleared when the device experiences like a low space warning. I forget exactly what the terminology for this is. But when like you want to take a picture and there's no room left, it will go ahead and see, okay, which apps are not open and which apps can I clear the caches for. And that will be one way. Oftentimes, if you have a lot of complex functionality in your app, you might have like a secret button to clear the caches on the user's behalf. So that way you can instruct them over email, like, hey, go to this screen, shake twice, jump around in a circle, and then you'll see a button that says erase caches. That's your secret button. Don't do this for everything. It like wastes a lot of energy and is kind of pointless in most cases, but it might fix the situation, kind of thing. So I'm not encouraging everyone listening to like put an erase caches button in your app. It's only if that is something that you found has been necessary over time, and instead of having the time to find out like why it's happening, it's easier just to have a button for it. Another opportunity for this is if in your user defaults, for instance, you save the last version that was launched of your app, which is a good thing to save in user defaults. You can go ahead and check that on first launch or on every launch. And if that version is not the same as your current version, you can go ahead and do things like clear caches proactively and make sure to migrate other things that are different between versions.
Gotcha. Okay. So I guess in a nutshell, it's like the caches folder it's persistent, but it's like a good citizen of persistence. Like it will, you're saying like worst case, if the user needs storage, you can get rid of it. It's not the end of the world.
Yeah.
Okay, cool. That makes sense.
Yeah, it's a great place for like putting images that the user has downloaded from the internet, so that way you don't have to re-download the image again. You can just look it up. Not saying that image is forever going to be like usable by you, so you should clean it up in your app if you know the user's never going to access it again. Sure. And if you use like NSCache, which is an object that's part of Foundation, I think, it will go ahead and use this caches folder. So it's not like you need to always use it yourself. There are plenty of utilities that do use it. If you use WK WebView, that uses the caches folder. If you use URL session, that uses the caches folder. So all of these things do use the cache folder, and you are invited to also use it for anything custom that you do.
Cool. That's really cool. All of this stuff, like for example this cache and stuff, I'm like, that's awesome, I want to use it, and I'm like, I have no current need for it, but I'd love to just make some sort of a test out for it, because I just want to kind of experience what it can do. But it seems relatively straightforward, where like you're saying, you can use a cache and do it that way, like an NS cache, or you could really, I mean, it's just as simple as instead of writing to the documents directory, you write to that. And there's no real difference, I suppose. So that's nice that there's no real learning curve, I suppose, there.
Exactly. And then the last like place you can store stuff is the iCloud key value store. So there are some asterisks for this one. The user needs to be signed in with an iCloud account on their device, which is fairly common at this point, but not ubiquitous. Like I've seen plenty of people's devices where there is no iCloud like account signed in. So that's something you want to keep in mind when you do use this. It won't be available in that case. You need to have an entitlement, which in the past meant that you cannot transfer your app between accounts if you decide to sell it later. That is now thankfully no longer the case. So good on Apple for changing that. Like last month, like very recently.
Very
recently. So good on them. And then from that point forward, you can use it just like user defaults. There are some severe size limitations that you should keep in mind. So definitely don't use this for like anything that is not user defaulty that you want to sync up. But for little pieces of information, it works exactly the same.
Yeah, as far as I remember, it's like 1 megabyte maybe of storage per app. Like a megabyte's like, it's a lot if you're just storing
text. It's a million bytes, Spencer.
I know.
That's a lot of numbers.
But, it's not half a terabyte like your phone has of storage. So be slightly cautious around that. It's either 1 megabyte or 10. I can't remember, but it's not much.
And I think each key has like 64 kilobytes of data associated with it. It's not much.
Yeah. Oh, yeah, that's right. Yeah. So it can be good. I've used it before. Yeah, and it's like NS Ubiquitous Key Value Store. It has like the longest name. Well, maybe not the longest name, but it's got a freaking long name. It's cool.
Yep. At this point, it really comes down to choosing what you want to save to something. And once you have a piece of data, you can save it to any of these locations. It can go in user defaults. It can go in the documents directory. It can even go in the Keychain if you really want to. But oftentimes it's difficult to choose exactly how you want to store your data in terms of data, right? Do you want it to be human readable? Do you want it to be quickly accessible? Do you want it to be easy to code? Do you want it to be very efficient, right? There's all sorts of different trade-offs that you need to kind of go for. And I would say probably one of the oldest and most well-known of these storage formats is XML. That's like the de facto one that kind of took the 90s by storm and has forever cursed us since.
Yeah. Yeah. What to say about XML? Okay. I don't personally enjoy it. I'm working on a side project with Ben that uses a lot of XML, and I have to parse it manually, and it's like, it's a huge... Well, okay, sorry. I'm parsing it manually because it's on Linux, and there's no XML parser or XML document to use. So there's that. That kind of doesn't help. But even the first-party APIs for parsing XML aren't, in my opinion, as nice as something like JSON, where you can just make a codable structure and it like decodes it all for you, and it's kind of magical and it works great. It's almost a little bit going. It almost feels like going back to the days of JSON serialization, where it's a little bit more manual than that. So I tend to stay away from XML, so my experience there is not great. So Dimitri's probably a better person to kind of really talk about pros and cons of XML.
Yeah, so let's talk about what XML is. So I don't think XML came before HTML. I think HTML was one of the first like markup languages of this style, but you have these open and closing angle brackets everywhere, and those refer to entities. So you might have say if you're storing weather data, okay, so you might have a day, and then in that day you might have a temperature and you might have a condition, okay? So in XML terms, this would end up being day within your angle brackets, and then some space later, day within angle brackets, but with a / in front of day to say that's closing out the day. And then in between those two tags, you would go ahead and put more tags. So you'd have one for temp, for instance. So you'd have open angle bracket temp close angle bracket 74, open angle bracket / temp close angle bracket. And that will go ahead and like signify, hey, that's the temperature for this day. And then you might have a second line with a tag called condition, and then a value within condition brackets tags. So XML uses this kind of structure, which has been made very popular by HTML. And you can go ahead and store all sorts of different types of structures with this, and you can describe exactly what your structure, how it works with rigorous rules using an XMLS or something. I always forget the exact sequence of those letters in that acronym, but it's oftentimes the very first line of your XML file. You're going to see that, and this kind of tells a parsing engine exactly if your XML is valid or not. And this is just a way of tooling, because initially these files were written by hand, so you'd want to make sure that they can still work. So as far as like written by hand goes, XML is a pretty good format for that, because you can read it by hand. If you open the file and you make sure it's formatted, you can go ahead and directly inspect things. You can change things easily. You can add or remove things pretty easily. So that's one of its strong suits. Now, anything that's easy for a human to manipulate usually means it's harder for a computer to read and make sure is valid, because humans can introduce errors along the way, or inconsistencies, or crazy variations that the computer wasn't really expecting. So that's where the difficulty with XML comes up, especially when it comes down to like parsing it by hand, like Spencer is doing, where he might want to visit his good friend the regex to help him do that or not. So I do want to clarify, HTML is not a flavor of XML. It is a different thing. It does not have the XMLS thing at the top. There was a flavor of HTML called XHTML, which was XML, but that was like long since dropped in favor of HTML5, which breaks all sorts of rules. Like, you don't have to have the low closing pattern at the end of like image tags and things like that. You can just say open angle bracket image source and then close angle bracket, and that's totally fine. So HTML is not XML, but if you know HTML, you basically know XML. It's just HTML with a bit more rules, and then a lot more freedom to have your own tags and stuff like that.
Right.
So yeah, if you want to use XML, it's probably because something is already giving you XML. It's not because you are choosing to like, I have a brand new storage format, that's going to be XML. That's probably not what's hip with the kids nowadays. So there is something that is hip with the kids nowadays, and that is JSON, right?
Yeah, JSON's great.
Quick, what does JSON stand for?
I know, JavaScript object notation. It's a bummer about that part, that it has JavaScript in the name, but JSON is, let's see, how can I describe this? It's like basically a dictionary or an array. And, you know, with children of, again, dictionaries or arrays for as long as you want to. But it's, I think the biggest strong suit for JSON is it's super readable. Two things. Super readable, at least it's way more readable to me than XML is. If I have to manually edit some JSON, it's just key value pairs for the most part, or arrays. But another huge thing about it in iOS land, or Apple ecosystem land, is it uses Codable, or you can use Codable with it, or JSON serialization, which is what we did pre-Swift 4, I think. Which was fine. You basically just would turn your JSON into dictionaries, Swift dictionaries. But now we've got Codable, which is sort of this really nice in-between of sort of intermediary between the JSON itself, which is just, you know, a text file with some structure for, again, saying if it's like a dictionary or an array, and giving children of key value pairs, to your actual struct itself. And a lot of cool stuff happens in the background to say, hey, this is my structure. I've sort of matched it to what the JSON is going to give me. Decode this and sort of shuffle those key value pairs or arrays over to my properties, and it's pretty much done. And again, you can sort of manually do it. But I think the biggest kind of strong thing about JSON is because of Codable, it's very easy to ingest that information and put it into something that's actually usable by your app as like a structure, a class. But also, again, going back to that student's whole thing was it's basically a one-liner to turn JSON data into your struct or turn your struct into JSON data and just save it out to, again, like user defaults, or sorry, not user defaults, like FileManager or something like that in the documents directory or anything. So I think this, for me, sorry, I'm rambling here. I think the biggest thing for JSON to me is like, it feels like a more refined, simple XML where they essentially do the same thing. The tags in XML are sort of like the keys, and then whatever you put in there is the value, more or less. JSON does the same thing in just a kind of a cleaner way where, for me, it's a lot easier to kind of mentally parse things and either write JSON manually or, again, let Codable do the work and just kind of have good JSON written for me, and I know it's formatted correctly. And again, going back to XML, there's no like XML document or XML parser that you need. It just kind of is all contained within this Codable protocol, and there's two methods. There's one initializer and one function that you need to implement if you really want to, and one enum, and that's basically it. So just kind of I'd say more simple and mature JSON or XML. I don't know how to put it. I'm interested to see what Dimitri has to say.
So I would say JSON is great because it's ubiquitous, right? Like every server on the planet knows what JSON is because every server needs to communicate with a client front end in some way. And that web front end, like its most natural thing that it's able to use is JSON, basically. There was like, let me see if I'm remembering this correctly. The very first like asynchronous API on the web was like XML based, I think, like XML async request or something. Like that was the actual like naming of that API. So it's interesting to see the web go from XML to JSON, even though like it started off like, hey, if you're transmitting data, like data looks like HTML, so XML is like perfect for arbitrary data. But JavaScript developers did a one-up on that, and they got together and they all thought to themselves, what is the laziest way we can represent data in? That's
awesome.
No, like let me go through this because it's gonna be a little eye opening. Because what JSON is, as you said, JavaScript object notation, it is basically how you represent an object, either a dictionary or an array in JavaScript. Like it's a literal of the language. And what you would do to consume JSON is you would say, hey, my variable equals eval, open parentheses, a JSON string. And you're just going to evaluate that JavaScript as if it were JavaScript. And therefore, you'd get some data that you can put in a variable. Like, it was that stupid early on, and that was the appeal of it, because it didn't require any parsing, it didn't require anything. It's just quite literally a JavaScript blob that you're importing into your software dynamically. Because JavaScript is a very dynamic runtime, and therefore you can go ahead and evaluate this arbitrary data that's coming in from the server as valid JavaScript, and therefore store it in a variable and do something with it and directly manipulate it, because it's not just a string at that point, it's structured data because you evaluated it as such. Now, that's thankfully not what you should be doing nowadays. Like, do not use eval for that, because that is like a ripe way to just have arbitrary code execution happen in your JavaScript application. So not recommended, but that is like the inception of JSON, and it's amazing that it has gotten this far for what it is. So we've kind of thrown out the typed data that is XML, and we've taken on board untyped data, which is JSON, because JavaScript is famously not type strict, in that you can be very loosey-goosey, see WAT. And
Yes.
yeah, I need to make a mention of that.
It's so good.
Definitely go see the WAT video. It is eye-opening in its own way. But yeah, that's like what JSON is in a nutshell. It's just the laziest conceivable way of storing data that someone thought of, and therefore we are now stuck with it as the de facto like communication like object format for the time being.
Yeah, I sense a little hostility there.
No, so for all the hostility that I bring up, I am like a champion of JSON in terms of its simplicity, because in terms of describing the data, you cannot get simpler. It's like very programmery. But like if you don't know programming, maybe it's a little tiny bit intimidating. It's like, why am I using curly braces and square brackets? But as soon as you learn at least one programming language, it becomes very obvious as far as like what the individual types mean. And it's very straightforward to go ahead and then use as a result of that.
Yeah, that's true.
And you might be thinking to yourself, well, JSON is not like super efficient. You're repeating the keys all over the place, and
sure,
like you can have some structure to this. Well, someone came out with a thing called BSON, which is binary something object notation, binary script. I don't really know what it stands for, but it is a binary version of JSON. So what I mean by that is instead of re-encoding the same keys all over the place, it's going to go ahead and just name the keys with a like shorter key, and then just reuse that over and over and over again. And it can be more efficient in how it's storing everything. So you might wonder, like, hey, like surely you wouldn't use JSON or BSON as the storage format for databases, but that's what MongoDB does. It just kind of serializes that to BSON and then has that as its storage medium for cold storage.
Oh, I didn't know that. It stands for Binary JavaScript Object Notation, so it's like a double acronym. Or what do you call that when it's like a... Yeah, anyway.
Yeah.
An acronym. An acronym.
Too many letters. But yeah, that's what JSON and BSON are. Cool. This like leads us to another format that Codeable like directly supports, and that isplists. And plists are very interesting because there's technically 3 different plist formats, right?
Yeah, I didn't actually know that until I saw this in the notes. So I've only used plists as XML under the hood.
Mm-hmm. Yeah, so those are the most common ones, right? Like, if you open a .plist file that you find in like a preferences folder, that's probably what you're going to see. However, the other 2 are also super common. You might have seen them if you've ever printed an Objective-C dictionary or array. Like that printed notation is the ASCII format, like as is. If you've ever opened up a .strings file that's been compiled into your app, it looks a little gobbledygooky. If you open that in Xcode, it will go ahead and like just see that, hey, this is a binary plist, and it will show you a dictionary of keys and values. So binary plists are just a little bit more compact and more efficient to encode and decode because they're not human readable, once again. Right. But there are 2 human readable versions. One is the ASCII plist, which is something that looks quite similar to JSON for all intents and purposes. It does have semicolons and other things that are a little different, but the flavor is the same. And then you have the XML plists, which will go ahead and more strictly type everything, so that way you can go ahead and see like what the actual values are. And it's quite easy for an XML parser that's not on an Apple system to go ahead and read one of those plist formats.
Right. Okay, that's cool. So with that, are you able to choose? Okay, well, let me put this in the context of like Codeable specifically. Are you able to choose which format it gets encoded to?
Yeah, so
Uh,
the plist encoder, so property list encoder, has a property on it of format, and I think you can choose
oh,
between the XML and the binary formats. I don't think you can choose
oh
ASCII
yeah.
anymore. It's like definitely from the next days, so it's a very old format, but I think it reads ASCII format just fine.
Yeah, I just looked it up in the documentation. It's just an output format property, but the constants for it are XML, binary, and open step. So
OpenStep,
yes,
yeah, that's the ASCII
most
one.
definitely, most definitely, and it says it's not supported for writing. It's only for reading old style property lists. So yeah,
Interesting.
that's gnarly old.
I think NS property list serialization supports the ASCII one. But if you do want to write it, once again, you just have to take your dictionary and dot description it. That is literally the ASCII format that you get printed to the console. So it does have its use, like it's super human readable, which is why it's used for like string descriptions and stuff like that. That said, Swift dictionaries and arrays do not use this format, so do not get them confused. It's strictly for the Objective-C ones.
Gotcha.
But yeah, so like if you are using Codable, property lists might be something that you want to reach for on Apple systems. Like if you're just once again saving something for your internal use, and it's not really going to exit your app in any sort of way. They might be slightly faster. They might be slightly slower. It's been something that's gone back and forth over time. So it really comes down to if you want to be easily opening this in other things. So one like huge benefit of property list files is you can drag them to your Mac and open them in Xcode and you get a nice table to like work with them. So it's like built-in easy UI to manipulate these, which you do not get with JSON. You have to have some sort of external app that can help you with that. So that's like the main win for property lists. I have not seen them be significantly faster or slower. Like, as I said, it changes every version or so in terms of which one is more efficient for any given moment in time. But if you are storing them, definitely go ahead and use the binary version because, once again, you can open in Xcode, so there's not too much loss in terms of your ability to read them there. And they are a lot more efficient than just using the XML version.
I was just looking to see what the default was if you didn't specify an output format.
I think it might be the XML version.
I'd probably assume it would. I guess the good thing about deciding between XML and JSON in the context of using Codable is if you are like using property lists as your kind of format, more or less, it would be very easy to load up your plist plist JSON, your plist object, decode it into just your Swift struct and then encode it back into like JSON and save that if you ever wanted to kind of like flip flop between them. So that's kind of nice, I suppose.
There are some things you should keep in mind that I'm reminded of right now. For instance, null values are not supported in the XML plist, but they are supported in the binary plist formats. And I think there are some similar restrictions in terms of like keys for JSON and plist. Like they're not intercompatible 100%. Like there are some gotchas. Do you remember any others?
I was the one that I was thinking of is I think you can actually just store like binary data in a plist, and I'm not.
Yes.
I don't think that's the case for JSON. So
JSON does not have binary data.
Disregard that. I guess if you wanted to like base64 encode it, you could, but yeah.
Yeah.
Okay. Never mind.
Codable makes a lot of that easier, right? It does know how to like save things like dates and things like data into JSON because it just serializes them. Butplists have native forms for dates and for whatchamacalls data that it can go ahead and know directly, hey, this is not a string, this is data. And in the XML one, it's going to be base64 encoded because you have to. It's a human readable format. But in the binary one, guess what? That's going to be super efficient. You're not going to lose a quarter of your your space just because you wanted to save some data into it.
Yeah.
So that's something to keep in mind.
Yeah. Okay. So disregard my earlier comment.
This leads us to like the big one of the storage formats, and this is CoreData. And CoreData is the big one because it can do a lot more than like plist or JSON files can. In fact, not all the data needs to be loaded at all. And this is what CoreData does splendidly. It allows you to describe, hey, what your data should be. This informs what the storage format is. That's why you need to do all of that schema and like entity stuff ahead of time. It's because that is directly describing your storage format. And then that storage format will be a hyper efficient variation of that that is actually SQLite under the hood, which we'll get into in a bit. But you can go ahead and once again, just load pieces of that data into memory at a time, and you don't need to have everything in memory. And that's what makes it very efficient for apps that need huge amounts of data. But I want to emphasize huge. Like for you, Spencer, what would be the cutoff point between like the ease of use of JSON files or codable files versus something full on like CoreData?
Yeah, I think it comes down to both size, but also complexity. Where, I mean, one thing of CoreData is you can have these relationships between these entities or these model objects, basically, and it makes a lot of that kind of stuff nice. Where you load up the parent, it also grabs the child objects and everything. So there are like a lot of things there, but I'd say storage or size wise, yeah, I mean, you'd have to have, I don't know. 1,000, 10,000 objects, maybe. I'm not quite sure. But going back to this comparison with JSON, JSON files are small, right? But if you ever try to like store even like, I've been working with some JSON files that are like a megabyte, 5 megabytes, and it doesn't sound like much, but you try to open that thing in Xcode, it will bring your computer to its knees just trying to open Xcode with a JSON file that large.
It's 1 million characters, Spencer. That's a lot of characters.
It could be 5 million. But my point is,
especially if they're on one line, Xcode is not happy. They better be on multiple lines, otherwise it's a lost cause.
Yeah, I mean, I don't know if it's quite that hard in an app format to just like load it up into some variable or whatever. But just going off of that, I can tell that it's a lot easier to pull, or a lot faster, I suppose I should say, to pull something out of CoreData. Like Dimitri said, it's just you pluck whatever you need. You're not loading this entire database of potentially, literally millions of instances of objects. But you just run a query and say, hey, just give me these things that match whatever this criteria is, and it's very, very efficient at that. So if efficiency and I hesitate to say like ease of use because it's not necessarily the easiest thing to use, but on a larger scale, you're going to save a bunch of headache performance-wise when you use CoreData.
Mm-hmm. And I wouldn't necessarily say you need to start with CoreData. Like it's very easy to start with JSON or Codable in general. And then when you need to use CoreData, it's as if you were going to use CoreData from the beginning. So it's not like any extra work to do that switch later. But as Spencer said, you generally know when you need to make that switch over when writing a new object to your JSON array starts taking a significant amount of time. And this is generally only once your JSON file reaches megabytes in size, because every single time you need to write to it, you need to write the entire thing to it. Single time you need to read from it, you need to read the entire thing from it. So it gets slower and slower the more you add. And there's kind of an exponential character to that makes it a poor choice for very large data sets, because your app will essentially get worse and worse over time as the user uses it more and more. especially if you're storing tons of small pieces of information. Generally, I would say you can characterize this as around 10,000 entities. So if the main thing in your app, like say our hypothetical weather history app, has like a day, and then in that day you have a temperature, condition, yada yada yada, UV index, what have you. Once you reach, if you think you're ever going to reach about 10,000 days, then you might want to like use CoreData from the beginning. If you know that, hey, your app, if it's running every day for a year, that's 360, and then like 3 years, that's going to be about 1,000. That means it would have to be running for 30 years straight to get to that 10,000 mark. You can probably save yourself and just skip that, because computers will get faster by then.
Sure.
So you can just stick to like a simple JSON format. You'll probably be fine for a long time. Like you can characterize that, because it will, like, it's every day your app is run. That's the most that you're going to add to it. So, and there are different ways about that. You can say, hey, maybe every year is stored in its own file, and that can be more efficient. But at that point, you're approaching what a database does. Like CoreData, what it's doing under the hood is it's using something called SQLite. And SQLite is a database format. And what a database is two pieces of information. It's a table, and that table is separated into chunks that are like put into different files in the file system. And then you have something called an index that is loaded into memory. So anytime you want something, it looks up in that index where it is in those tables, and then it will say, okay, we need to load file 7. It loads file 7, which is a small amount of data, and it grabs just what it needs. It just jumps right to it and then grabs it. If you need to write a new thing to your database, it either goes to the end, which is very easy, or if it needs to go in the middle, it's just modifying one file or splitting one file. It's not necessarily doing a ton more than that. However, there's that level of indirection that you're dealing with. You need to look up in the index first, and then you need to go to a file. And therefore, there's a little bit of latency for everything that you're doing, as opposed to dealing with that latency at the beginning where you load everything in memory, which is what you're doing with JSON. So there are always trade-offs there that you should think about. As an exercise, you can totally make your own mini database. You can have different files of JSON and then an index JSON that links everything together. That's totally fine. That's essentially what a database is doing. And if it works for your needs, it might be way simpler, right? Yeah. You don't have to have all the bells and whistles that CoreData enforces upon you to have something that works very similar to CoreData, and you learn at the same time. So it's a win-win for you. If you do want to go that route. So you can probably tell I've been burned by CoreData one too many times, that I just don't want to ever reach for it, and I will go to exceedingly stubborn lengths to avoid using it, all in the name of learning. But yeah, it's something that exists, and it's something that works well for a lot of people, and it's something that works very poorly with Swift. And yeah, it's great. I love it.
Yeah. Well, a good thing that it's I mean, they're kind of making it a little more integrated with SwiftUI and stuff. I don't know.
I don't think they did anything recently.
Well, okay,
just take optionals. Just take optionals, for instance. It's a whole mess. There's optionals in CoreData, which are not optionals in Swift. Right. All numbers are yeah, that's not actually. You chose N64 in the dropdown. That's cute. That's not an N64. It's just a number. So yeah, there's some idiosyncrasies with CoreData and Swift that make it a questionable choice nowadays. But once again, it's way easier than learning and dealing with SQLite yourself, but potentially way harder than just writing your own index file. So I don't really know where a good trade-off for that is.
Yeah, that's interesting. I mean, yeah, I would definitely not dive into the SQLite myself, but I don't know. I feel like I have had a somewhat decent experience with CoreData, although I'm positive that I haven't used it on the scale that you have. So there's,
I have not used that at any scale. I just got burned early on.
Oh,
I will fully admit that.
okay.
I reached for my first migration and things went poorly, and I was like, yeah, this does not feel worth it in my very inexperienced usage of it so far.
Okay. Yeah. Okay. So like there is a huge learning curve. Like uh, figuring out Codable and JSON, like there's a learning curve, but it's fairly small. CoreData, like Dimitri said, I mean, it's got optionals, it's got transient things, it's got migrations, it's got these relationships, and there's a ton to it. I'd say, I don't know, Andrew Madsen was kind of the one that taught CoreData when I was learning. And he's I think a pretty big champion of CoreData, and so I got like a good positive like perspective on it, and so when I've used it, it's been fine. It's definitely more work. Like the amount of work that you have to put up front just to get something working is much larger. I will say that for sure. So again, if you want to get something up and running quickly, honestly, like Dimitri said, it might be easier to just write an index of JSON files yourself and just do it that way. But I think CoreData is useful. I agree that it's like not the most fun thing to use in Swift, and in general, it's not. I mean, I don't think it's been supported or updated rather in a long time, really, except for adding a couple things to Swift UI a couple of years ago. But I think it's worth learning about. I know that at work we use it for our internal database, so it's like it's not like no one's using it, but I don't know. That's a sample of size of one, so I don't know how many companies are using it as opposed to other means.
Mm-hmm. And to be clear, like it is used a bunch. It is not something that is not used at all, and it works well for what it does, and it has relatively few bugs for the lower level things. Like there have been bugs in the past, especially when you want to use like magic. Some magic pieces of it is like, oh yeah, automatically store this as an image file for me, please.
Oh yeah.
And that like stopped working for one OS release, and that was like enough to like burn it again, and like ruin my efforts to try to embrace it once again. Yeah, I'm a bit jaded, but it is definitely being used, and there are definitely workarounds for like those pieces that are on the flakier side. I just wish that Apple perhaps put a little more care into migrating it over to Swift and showing that it's still something that they care deeply about, because it feels like it's just sitting there and being like on maintenance mode. And to be clear, tons of Apple apps themselves use it, so it's not like it's completely foreign, and you can go ahead and inspect, like unarchive their show contents or whatever it's called, and see the entity,
the database
files that you can open in NSCoding and see the map. Like it's all there, and it's not really being hidden for any practical purpose. But yeah, it is something that is perhaps a bit more complicated than it should be, probably because it is trying to model a bunch of complex behaviors that maybe a lot of people need, but maybe a lot of people don't, right?
Yeah. I mean, I just think about like I've been using Postgres a lot with Vapor, but similar functionality to like SQLite in the sense of like the raw usage of it, and like I wouldn't want to be writing filters and queries and stuff for the SQLite database directly. So like having CoreData as an intermediary between you and the SQLite is like, it's nice in that sense for sure. I mean, you get type safety for the most part, I think. Again, it's been a long time since I used CoreData, but I mean, you get a little bit of like Swifty Objective C creature comforts. You're not working with strings all the time, but it's definitely not the easiest storage medium for sure.
I mean, imagine result builders for like queries.
Yeah.
Like
That'd
that
be cool.
could be so nice to be able to use, and it doesn't necessarily need to be tied to SQLite. It can just be a custom binary format. It's not like SQLite is the be-all end-all of database formats for files, right?
Yeah.
Nowadays, like, yes, it is efficient, but like you can lose a tiny bit of that efficiency if it makes it easier to interact with from things like Swift.
As far as I know, I think you can actually set CoreData to use different underlying databases than SQLite. I could be wrong though.
Yeah, you can choose plist, I think, which is probably
Oh,
not a wise choice.
well, okay, all right.
But yeah. So yeah, CoreData is a thing that exists, and
It is.
what was that famous? It remains a product in our.
Yeah, I know what you're talking about. I don't know. It remains a product in our lineup.
Yeah, it remains a product in our lineup. That's
Yeah.
the feel that I get from it.
Yeah, I get that. I get that.
So moving on from CoreData, there's one more like Apple technology that is thankfully being phased out but still exists, and that is NSCoding and KeyedArchiver. So this was pre-codable, Apple's way of encoding like objects into things like plists. Because that's where you'd often want to store them. Like one of the most common things before Stack Overflow was, how do I save a color in my property list? Like the user chose a color for their calendar, and I want to save that in the user defaults. How do I put this color thing into the user defaults? Because there's no like set color for key. And the answer to that was to encode it using KeyedArchiver, and that would turn it into a bit of data, and then you can take that data and turn it back into a color down the line. And yeah, this was Apple's like binary solution to that. I don't remember if they use plist. I think binary plists use a format of KeyedArchiver instead. Like it's all like interrelated in that way. But that meant it can be very efficiently saved as a result, because it's just a subtree of that same binary format. So that's what NSCoding and KeyedArchiver are. I would not suggest continuing to use them nowadays, though you might have to use them for things like state restoration and stuff like that. But you can always just save a JSON blob to a key and call it a day. As inefficient as that is, computers have gone fast enough to deal with our little problems like that, right?
Yeah, this sort of predates my iOS experience a little bit. I know that they exist, and I think I used them a little bit early on, but yeah, my experience with like NSKeyedArchiver is pretty limited. So I haven't used them really personally. I know that in LumaFusion that we do use it fairly extensively, and I think slowly we've been moving things over to using Codable instead, kind of as an alternative, like Dimitri said. So yeah, I don't have much to say about that.
Sounds good. And that leads us to the very last like type of format, and that is the all-encompassing one, binary format. And there are tons of different serialization like patterns that you can follow, and it's really up to you to just choose one if you want to go down that route. A very common one nowadays is protocol buffers, and this is because protocol buffers are something that Google invented for some RPC like format that they were trying to push over like passing JSON around. And that's because they're very efficient to encode and decode. They are typed to like the code that accesses them is auto-generated based on a schema. So it makes programming easier, even though it makes it harder for people to jump on board. But once you have the tooling for it, it's easy. And yeah, I would say those are the benefits of it. Along with a lot of that tooling, there's a lot of unknowns unless you know about them, of like what happens if data will not match exactly. Does that crash? Does that error? Who knows what it's going to do? So do always keep that in mind whenever you're using these like pre-built libraries. But because it is a stable format, you could ostensibly write your own reader or writer or serializer for protocol buffers. Another super common one is a format called atoms, and these are used in media files. So if you've ever wanted to know what a video file looks like, it is composed of atoms, and atoms are very straightforward. It's a 4-letter keyword for a specific atom, and oftentimes these are in ASCII, so you can actually see them. And then it's followed by some amount of bytes that describe how long the rest of it is. And there are a few different atoms with a few different flavors. So you might hit an atom that you don't know what to do with, but you know that, hey, if you read ahead the X bytes because it tells you X right afterwards, then you can skip that atom and go to the next one, and so forth. So atoms are a very compact way of representing structured data in a way that you can extend it over time, which is why they're used for media formats, because you might have a new encoder that comes out, like H.267, and H.267 is not known, but the same audio is being used, so you might be able to open that file on an older computer and still hear the audio but not see the video. That could be like an outcome of doing that. Or it might just say, can't read this. So that's oftentimes what happens, even though that's probably was not the original intent of that format. But they are reasonably easy to kind of wrap your head around, especially because they're well documented. So that's probably the theme of binary formats, is document them, because they are not going to help if you don't have any sort of documentation as far as how to read data out of them, because they are as compact as possibly can be, right?
So I guess it's sorry, I'm not. It's sort of like for the sake of efficiency that you would do it in like a binary format.
Yeah.
Like take out the human readable part and just compress the crap out of it, just so that you can get it as small as possible while maintaining all the information you need.
Yep, essentially. There are some very practical things that you can do with binary formats. You can use the same memory model that your system uses to directly archive things like structs into data. And what this means is you can memory map that file back to memory and just cast the first thing you see as a struct. And programming wise, like you're in for the home stretch there. You have a pointer to data that represents like directly manipulatable data for your app. So there's no load time there. In fact, there's zero load time. You just basically said, hey, make this data available to be read and written. Like if you write to that memory map, then it writes back to the file. So that is something that you could also do with binary data that you can't really do elsewise. And that's probably why they were used so much early on, is because like that's once again, think of the stupidest way you can serialize data, and if you can just take the memory that you're working with and put that in a file, that's quite literally even stupider than JSON. So that is an option that's available to you if you really want to do it. Yeah, and if a little shout out, if you do want to read and write binary formats and serialize stuff yourself, oftentimes you might need to do this to wrap some sort of data together. There's all sorts of reasons why you might want to consider it. I have a library called Bytes, which makes it easy to read binary data in Swift and manipulate it in Swift. Basically, just an array of uint 8s at this point, because that's what a byte is. But it has a bunch of helpers for like parsing strings out of that, or parsing numbers. One thing I want to shout out, if you are like inventing your own thing, always use big endian variations of numbers. Numbers, it turns out, are super complicated. Take this English sentence, for instance. I love the number 17. You are reading this left to right, right? So you're accumulating information as you go along, except as soon as you hit that number, you are now flipping your mental model of it, and you're reading the least or the most significant byte first, the 1, and then get less significant with the 7. So if you have a large number, 1,752,512. The 12 part is really insignificant in the grand scheme of that number, right? But the 1 million part is very significant. But you reach that significant part first rather than last.
Right.
So that's what's called big endian, because you have the big end up first. Little endian is you have the little end up first. So you start with the least significant, you build up to the most significant. And it turns out that's a completely valid way of working with numbers. It's just not the same on every computer. So, and especially it's not the same to us humans. Like when we think of a number programming, like whatever you type in code, it gets turned from big endian, what you typed, to little endian in the compiled version, because that's what is more practical for that type of computer. So for that reason, it is encouraged to serialize in big endian because that's like what we think of. If you look at an XML readout of a number, that's always big endian. Like the little ends are always on the right side. And like we're just naturally used to that. So
Right.
do make sure that if you're storing any data in binary, always save it with the big endian like order for numbers. This only matters when you have more than like a single byte. Like if you have 2 bytes or 4 bytes for a number. 1 byte obviously is just that order. I think all bits are automatically translated. Like it's not a concern. But yeah, something to keep in mind as you're like communicating between computers or just saving stuff in general, because the next computer that might come out, you want to know if it was in big endian or little endian. Otherwise, your number can flip drastically in terms of like size, right?
Yeah, that makes sense.
So yeah, that's my only like pointer for binary stuff. And yeah, if you want to use it in Swift, check out Bytes. Helps.
Nice.
Any other storage formats that you can think of?
Not really. I mean, you've got like you mentioned MongoDB, and I mentioned Postgres, and there were kind of like other things adjacent to like SQLite, MySQL, all that stuff, NoSQL. But I'd say that in general, they're more or less the same. If you want to learn about them, there are of course differences, but more or less it's just kind of this, like Dimitri said, relational data. Well, not NoSQL, but in general, it's like a relational database, and it just kind of is built specifically for efficiency. So, yeah.
And because database writers wanted to use JSON in some way.
Yeah.
But yeah, as you said, it's a difference in mentality versus thinking about a table of data. That's where SQL databases come from. And NoSQL is, instead of a table of data, you have an object graph.
Yeah.
And that's what CoreData is trying to do. So CoreData is trying to turn your object graph in memory into a table of data on disk. And there are efficiencies of thinking of things as tables of data. So that's why like we do it. If you have a dictionary, like an actual dictionary app where you look up a word, there are hundreds of thousands of words. So you want 1 entry per word, right?
Yeah.
That's generally what you want. Versus if you have a family tree, you could think of it as a table of people, but that's not really what it is, right? It's a tree of people. So there are different ways that you might want to organize that. It all comes down to serializing it as a list at the end of the day. Like memory is a list of things. And there are efficient ways of doing that. And that's why you take computer science classes. But if all you're interested in building an app, then you can generally pick from the above and probably be fine, I would say, for your entire career. Yeah. This week's episode from Code Completion. This week's episode of Code Completion is once again brought to you by Super Easy Timer. Super Easy Timer is a quick and easy way to use a timer app for your Mac. It's completely text-based, so you can type in English what you want, 20 minutes or 5 p.m., hit enter, and instantly start a timer. The timer understands English text to create, update, and start a new timer. You can quickly change an active countdown, even while it's still counting down. There are simple keyboard shortcuts to reset or pause, no menus, no sliders, just use English to control your timer. We want to thank Super Easy Timer for sponsoring our show. Search for Super Easy Timer on the Mac App Store today to give it a try. So it's been a while since we had a last mini review corner, and we've actually talked about this one slightly in the past, but you finally got a chance to install something. Want to let us in on it?
Yeah, so Dimitri, back in his mini review corner, I think his Logitech Circle camera, I mentioned I whipped out this doorbell that I've had, this Logitech Circle View doorbell that I've had sitting in my house unopened since December. And I was like, you know what? I'm going to put it up. So that's what I did this weekend. It was a whole thing because the doorbell in my house is like digital and the voltage was too high, and so it wouldn't actually power my doorbell correctly. So I had to run to Home Depot, get an old school chime, like physical doorbell chime with a separate transformer. Got that done. Anyway, whole thing is to say it works great. I sent a Slack message out to the group and I was like, this is awesome. I have HomeKit secure video. I see when people deliver things on my front door from Amazon and it records and stuff and it's great. And then sunset comes around and I'm in Utah. So it was like 95 degrees yesterday. And the stupid thing goes offline. I get a notification and I go into the HomeKit app and it gives this wonderful message. Let me pull it up. It says, this camera needs to cool down before it can be used. And I was like, oh crap, what have I done, man?
Just need to throw water cooling on it.
Yeah.
By water cooling, I mean spraying it down with a hose.
Yeah. Oh, man. And I start looking at... Okay, so like the thing is, I got this in December, right? And there are not many doorbells for HomeKit, and so my options are limited now, but I think they were very limited back then, and there was a lot of hype building up to this one specifically because it was like promised to be like the first HomeKit secure video camera and everything, as far as I knew. Mm-hmm. So I got it in December. My parents got it for me for Christmas, and I just barely am installing it, so like way past a return period. But yeah, the whole thing is like you go online and on Reddit and stuff, and it's just like everyone's is overheating. So it's not this like it's a very common thing. It's not like
it's made for cooler climates.
Yeah. So I mean, if I lived in Seattle or something, that'd be good, but I don't. So so anyway, I think it's just a matter of it thinking it's overheating by when the sun's like directly on it. I've got a little awning and stuff, so it doesn't happen during the day, but as soon as the sun actually hits it directly, it's overheating. So there are a couple options. There's people make like 3D printed brackets that you can kind of screw around that cover like the top and maybe the side where the sun comes in to block some of the sun and stuff. I don't have the right plastic to print that for kind of a good weather resistant plastic. So what I opted to do was go to my parents' house because my mom has one of those Cricut vinyl cutter things, and I put in I made a white vinyl sticker for my doorbell, which is like, I mean, this is yesterday that I installed it, and also yesterday that it started overheating. So I have 1 day of experience with this thing. So time will tell this evening, when the sun sets, if my doorbell overheats again, or if I need to get a 3D printed bracket or something. Because like I don't want to return, or I don't think I can return the thing. It's like I want the HomeKit secure video, so my options are limited at the moment. So I might just have to limp along with this thing.
Work within your constraints, right?
Yeah, that's awesome. I love doing that.
Is it only going to get better during the winter as the sun like goes down and then hits it more often?
Maybe, but like I think the overall ambient temperature is going to probably help with that. I mean, we're like kind of in the dead of summer, so maybe it's like this targeted issue where it only happens for like 3 or 4 months out of the year. I don't know. Mm-hmm. We'll see. I mean, it's snowing for almost half the year here, so hopefully it works. But my initial experience was like, this is great, I love this, and then my 24-hour experience is like, oh crap, I've definitely got the wrong thing. So time will tell on the longevity of how long I keep this thing around.
Mm-hmm. No, I think it'll probably work a lot better with some white reflective covering on it, because I don't know why black was chosen. It's the hip choice, I guess, and probably doesn't yellow in the sun. Yeah. But yeah, it's going to get hot as a result of it being black. I was going to suggest, you can probably put foil too, and that would like reflect even more heat, mm-hmm. but it would also reflect all the Wi-Fi. So that would probably not work too well for your use. Though I would imagine the Wi-Fi is probably like on the back of it to beam into the house as much as possible rather than like radially from the doorbell.
Probably. It's worth. I just have this shiny foil. I mean, it's like
look into the camera. I can't. It's blinding.
Yeah, the side of my house is gray, and so like it was not. It looked really nice with just this black doorbell right there, but now it's like this just big white spot on my wall, and I can't even imagine how much worse it would be if I just stick like aluminum foil on it.
And it's not even like perfectly straight; it's all crinkled and stuff because
Yeah.
it's like impossible to keep it perfectly polished.
Oh man. So time will tell. I don't know. I'm cautiously optimistic about this thing because I mean, someone took the time to make the Cricut file and throw it on Reddit for other people. It's like this far-reaching issue. So I just hope that it helps in the place that I live.
Mm-hmm.
We'll see.
Yeah, I have a few of those circle view cameras now to the point where like on HomeKit I get the new organization on iOS 16 where you can like see multiple cameras at once. So that's definitely neat. And the little ones have not overheated so far in the directive like sun vision. Because we have one that I mounted on top of our garage to kind of see the road traffic as we pull out because you can't see it from the foot level. And that one is like pointing at the sun all day, like from morning to night. And our doorbell would ostensibly do the same thing because it's like facing the same direction. So I was joking, like with winter, it might be worse because then the sun is lower and therefore always hitting it versus the ambient temperature being down and the direct sun temperature warming up the nice little black casing.
Yeah, that's a good point.
But now that you covered it with something white, that will probably work a lot better. So when it comes time to me finally like being willing to punch a hole through the wall to put the transformer and everything and getting one, I might ask you to make me a nice little white cutout sticker to put on it. Yeah, the outside of our house is white, so that would be perfect. It would just blend in.
Okay. You thought ahead, obviously, for this specific targeted problem.
I bought the house that was white because I knew the doorbell would not work.
Darn you, Logitech!
So, got to throw logic at it, right?
Yeah. So you said your cameras aren't overheating though?
I don't think so. I mean, I can check right now.
Like you never get like the notification that it says like it went offline or anything?
No.
In the middle of the day. Wow, that would be nice.
Nope. Works fine, and you can hear the wind.
Nice. Well,
Slow rumble. So yeah, something to look forward to, I guess, for myself.
Spencer is again the big sad right now. It sucks, dude. You'll find
out today, right? If it works.
Yeah, it's supposed to be like stupid hot today. Oh well, 93. Throughout the week, it's supposed to get to like 96.
That still counts as stupid hot. You can anything above 90 counts as stupid hot. And then over 100 is stupid hot, and over 110 is this is a place we live in now.
Yeah, I've only been to Las Vegas a few times, like stayed in Las Vegas instead of passing through to like go to California or something. But there was one time it was like at least 110. I want to say it was 114, but it was like when I was, I don't know, 15 or something. But when the wind is hot, that's when it's like, no, dude, you can't even get any solace from the wind. Mm-hmm. That's the absolute worst.
And I think the even worse than that is going from the air condition to the hot. The hot air literally crisps your lungs, and that is something that you might not have ever experienced from more humid climates, where it's just miserable and sticky. Mm-hmm. It's not painful. And 110-degree weather, like entering into your lungs, is painful. Your throat closes up on you and says, "No, I do not want this. Please, please revert back." But it closes up on you, so you can't breathe anymore, and therefore you may not be able to go back. So it's like a new level of discomfort that I don't think a lot of people truly appreciate until they feel it. So yeah, dry heat, no fun.
Yeah. So, I'll update you next week on on my doorbell adventure, though.
Definitely, I'm looking forward to hearing it be successful because that would be like it's the only one.
Somebody else just, and it's like Logitech. It's like not some random brand either.
Mm-hmm.
Like it's surprising that they just like crapped the bed in here and just made a super bad product. And there's like warnings, I think, on Apple's website even to, like about the like temperature issues and stuff. Like it's that.
You'd think they would have printed
profound.
a white case by now, right?
Yeah.
Like
guess.
that would have been the obvious solution. It's like, hey, black. Like if you really want to, and your front door is facing the north or something, and therefore you do not get the sun like hitting on it, then that would be excellent. But if you're south facing, like pick this white one. It reflects a little more.
Yeah.
So as always, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at CodeCompletion to know when new episodes get released, and feel free to tweet at us if there's ever a topic you'd like for us to dig into. Most importantly, as a small podcast, please be sure to share this with your friends and family who are also interested in any part of the process of app development. It's your support that enables us to continue doing this, and we hope to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who's at Spencer C. Curtis, that's SpencerCurtis on Twitter, for joining me this week. My name, once again, is Dimitri. You can find me at Dimitri Buniol, that's DimitryBouniol, and we'll see y'all next week.
Bye.
So, before we let everyone go, I want to tell us a story of sad of my own. Oh no. So, this past, like, I am slowly... let me preface this. I'm slowly getting this office ready to have a mini split AC put in, so that way we don't need to run the whole house AC for this office, which is basically the only room in the house that becomes truly unbearable when it's over 90 outside. Because one, the afternoon sun hits right this wall right here, and therefore it like heats up tremendously. And two, all the computer equipment that runs basically 24/7 is in this room, and therefore that heats up the room quite significantly. So I wanted to put a mini split in here just so that way we can keep this room like at a reasonable below 90 temperature. Like indoor 90 is not fun as much as outdoor 90 has like sun, not sun but like wind to help cool you down a little bit. This one just has fans. So I really wanted to put a mini split, so I purchased one. It's going to be available for me to pick up in 10 days ish. So we've been doing the work to get everything set up for that. So that includes bringing over 240 volts to the side of the house. So it's coming all the way from the other side. So need to put conduit on the roof and everything. And one of the things that you do when you put conduit on the roof is you want to raise the conduit so it doesn't stop the water and cause it to pool. As you can imagine, working in 90-degree weather on a roof, it gets hot. So we were trying to limit our working to either in the late evenings or the early mornings. So we did all this work, and the only thing left was to lift up the conduit with little pieces of wood that we cut, and to glue the wood with tar to the roof so that way it wouldn't move over time. Now we already like installed the pieces of wood and like screwed the conduit to it. The only thing left was to squeeze some tar and like glue it onto the roof. So, I waited for a morning to do this. And on that morning I was working and I had a brief moment where like I didn't have any meetings. And so therefore I could go climb up on the roof, and go do this. So meanwhile, I've been sitting in my living room because it's nice and fresh, big open space there.
Sure.
On the cooler end of the house. And I've just been using my M1 Max Mac, the MMM, Mac. So I've been using that, just sitting in the living room, nice and comfy with fans blowing on me, like chill. And I've been doing that for a few weeks at this point. And therefore I'm like, okay, I have a moment. Let me go put some shoes on, climb up on the roof and do this. So left my laptop on the table there, climbed up onto the roof, glued everything, climbed back down, and noticed immediately something was very off about my laptop. And the thing that was off was it was very bright in one corner of it, in the top right corner specifically. And the rest of it would seemingly not respond. And upon looking closer at the little bright spot, I noticed there was some like teeth marks. And I don't know if you can see this here without too many reflections. But my cat, turns out, had a very fun time chomping on the monitor screen and punctured through the screen to the metal, mind you. Like, there was a little bend on the metal on the other side, and I completely destroyed the screen. So there are some fun observations for this. One, I noticed the backlight still worked, so that was cool. And you can see, like, I have that new screensaver where you have all the little like directional vectors kind of flowing in different colors. I don't know if you've seen that one. You can tell that screensaver was on because the backlight would do that pattern, even though the whole screen was black. So that was neat. So that still was working totally fine. I was still able to VNC into the machine to like get stuff off of it, so that was totally fine. And I want to absolutely remind myself that I am exceedingly privileged in that I have many other computers to be able to do work on. So I was not disturbed in the slightest of not having my computer for an extended period of time, despite me like owning the agent of chaos that broke it. And and so it was unfortunate, and it is something that I did fully expect to need to pay for. It's not like accidental. I'm not gonna go to Apple and say your computer spontaneously shattered on me. Like, I own up that my cat ate the computer, and it's a funny story because you can say, well, you know that story where the dog ate the homework. Well, in my case, my cat like destroyed my computer. So I had a fun time sharing pictures with people at work and stuff. That is something that happened. So it thankfully happened a week ago, and therefore I've had the chance to go through the whole cycle of fixing it. So I was able to take this computer to the Apple Store, and I did my whole practiced explanation of how this happened, because you need to entertain the genius at this point. It's a funny story, and it's silly. And he says, you know what? My cat did the exact same thing, but it was with the older MacBook Pro, and because that one had more bezels around the screen, and therefore not an edge-to-edge screen, it survived to tell the story another day. So they were like completely on board with the craziness that happened, and awesome. Thankfully I had Apple Care Plus, which I think it's just the default now, because I didn't really notice choosing that over the regular one. But that means that any screen damage, accidental or purposeful by Agent of Chaos otherwise, is completely covered in that $100 deductible, whatever you want to call it. So it's really nice that warranty meets insurance nowadays with Apple Care Plus. Because that saved me roughly $900 of screen replacement. So you only had to pay $100. That's it. Yeah, I only had to pay $100.
Nice. That's great.
So I brought the laptop to the Apple Store, dropped it off. I didn't need to pay anything until picking it up. They asked if I wanted to have it shipped to me or pick up in the store, and they told me it would be shipped via FedEx or UPS. I asked if I can choose, and they said no, and therefore I immediately said to the store, please, because FedEx is super flaky, and although they deliver horses or something and they're great in that regard, they suck at delivering stuff consistently to my house on time.
Wait, hold on. No, they're good at delivering stuff. They may just drop kick it in the process. That's the only thing.
No, sometimes they don't, and they just say, oh, it's been sent back to our warehouse and you're never going to see your computer again. So I don't want that to happen to my work computer. That, yes, it could go poof, and I have backups of it, but no, I don't want to restore from backup. That's 4 terabytes of misery. So I opted, let the Apple Store be responsible for this. I will come pick it up. And I went to pick it up, and they brought it out brand new, or new. And it had a new screen and a new screen cable, which they damaged in the process, I guess. If you're just gonna replace the cable, just say replace the cable. Don't say it's damaged. I didn't damage the cable. Come on, it's been very carefully cared for, other than being left on a table with Agent of Chaos named Keychain.
Okay. That was my next question, was which Agent of Chaos is it?
They are both Agents of Chaos, but this one likes rubbing her face and biting on things. And thankfully most things are thick enough where she can't really get a good chomp on it. But yeah, it's times like these I'm reminded that cats are predators, and they have the chomp that is fully capable of like doing absolute damage to not only computers but like flesh and stuff like that. And when they give you little nibbles, they are really giving you nibbles. They are holding back because they don't need to hold back. They did not hold back on that laptop screen. I can tell you that much. That is some hard piece of metal and glass, and they chomped right through it. So yeah.
If it's denting the metal, that's pretty crazy.
She's sharpening her murder fangs. So yeah, like your pets, both dogs and cats, like you wrestle with them, you have your hand in their mouth, and they are consciously not chomping on you, because guess what? Those chompers are made to like tear off meat off a bone, and I don't know about you, but tearing meat off of raw bone is not easy. Especially when you're like prepping it. Like, sure, if you cook it for 7 hours, it falls right back off. But like, we've all experienced some occasion where it was not nearly as simple. So yeah, they are equipped with that hardware, and they will use it on your computer if left open. So keep in mind, if you also have agents of chaos living with you, do not leave your very, very, very expensive laptop screen just open next to it, especially if that's your like only way of doing work, because that took a week. They said I brought it in on a Monday, and they said this is not going to be ready until Saturday, which basically means you won't be able to pick it up until Monday because there's no deliveries on Saturday. Thankfully, it was available on Friday, so I got to pick it up 2 days ago as of this recording. And yeah, I now have my laptop back, which I am very happy for. So.
You were the big sad, now you are the big lad.
Yep.
Very nice. Very nice.
So, yeah, that's my lesson to myself. So I don't know how much everyone knows about my like current cat problems, but we have like some bladder loose cats around the house, so therefore we've like gotten very good at not leaving anything out. And putting everything away in this office, like the chaos that is in it remains closed to them, because they might just leak pee all over anything. And I thought 5 minutes was a safe amount of time for me to go up on a roof, but I have yet again been reminded not to leave anything out. So yeah. That's all I got.
All right.
As far as titles, which one do we want to go for?
Let's see.
Took the 90s by storm and continues to curse us. Always good. Even stupider
good.
than JSON, I think, is a winner.
That's pretty good.
In my mind.
It's going to be controversial. Calling JSON stupid. It is beloved.
Yeah, but binary is stupider than JSON. Or no, not binary per se, but directly serializing to memory. Like that's pretty stupid nowadays. Like, don't do that. Even if you're thinking about it, it's like, oh, that sounds so cool. That's how memory exploits get made. Yeah, like all that wonderful Ocarina of Time from your childhood being hacked in real time by a person with very fast thumbs. Yeah. That's this problem basically. Do not just like load stuff up into memory. Bad idea.
Yeah. Good old arbitrary code execution, baby. It's like, it's so funny because like we were talking about that in the context of an app, and I'm like, oh yeah, that's awful. But then I started thinking about like Ocarina of Time speedrunning. I was like, it's so cool though.
Yeah. No, it totally is. There's a new exploit for Breath of the Wild I just saw.
I saw that. It's crazy.
Where it's like you just hold stuff in your inventory and then like switch save files 17 times, spin around and do like high fives with your neighbor, and then all of a sudden you have infinite something. And it's just like, yeah, there's definitely some inkling, like we're inching towards arbitrary code execution by doing this little by little, by manipulating data in this way, and you can definitely feel it, right? It's very much the reverse bottle adventure for Ocarina of Time, where it's like you hold a bottle and then now you have inventory items that you didn't have before, is because you're just sliding around a memory pointer and it's potentially going too far. Who knows?
Yeah. It's interesting though. Like, I wonder. Okay, so like we've talked about this a bunch with Ocarina of Time, but it was like a launch game. It was like a new language. They didn't really know what they were doing and stuff. But like, I wonder though, like, would all of these things have happened in Breath of the Wild if they wrote it now? It's like, I don't know what language they're using, but like at the very least, they know a lot more about the engine and stuff. So, be interesting. Like, was it?
I
Just
feel
a
like they
similar
know
thing?
less about the engine. The engine has become more magical in the way. Like by like throwing physics at it, it's like, well, the math does stuff. We don't really know what it's going to do in various situations, but the math does stuff. Like that
It
feels
does
more
something.
magical, right?
That's
So,
fair.
like I feel like these kinds of exploits, like it's just a matter of time before they are found for Breath of the Wild. It's not like Nintendo is trying to prevent their games from being exploitable.
Yeah.
Like it's not a kernel, right? It's something meant to let people have fun, and you need to make sure that the game does not break. That's the number one thing. So anything that does not completely break the game via like intentional progression through it, that's probably all they care about. Anything like completely obtuse, like loading a save file 3 times and then like spinning in a circle and then holding things and then unloading Link's model and then like going through that whole sequence of events.
Like, not everyone's gonna do that.
No, and if someone does do it, they're gonna think it's funny because it's
Yeah.
like something so obtuse that they were trying, and it's like, hey, look, Link is a bald head just floating there,
Yeah.
and that's just something that like happens over time, and yeah, it's cool.
It is cool. It's cool to see. I mean, like Ocarina of Time. How old is it now? Like 25 years or something. Still going strong because of all of the. I don't know if people would be speedrunning it if there weren't, all of these glitches to take advantage of. Because then it would be like a 10-hour game or something. So
Yeah,
kind of cool.
I often wonder if like games nowadays have a chance of reaching that because back then that was like there's only so many games, right? And nowadays like basically anyone can put effort into making a game, but then it has a much lesser chance of becoming popular as a result of there being so many, and therefore like tons of games may just never be remembered as a result of that, right?
It's
And
the App
that's a little
Store.
sad. Yeah.
Yeah. It's the exact same thing.
Like, I don't think we're going to see emulation for iPhone OS 2 apps because there's just, like,
Right.
no one has the apps anymore, right?
Yeah.
It's not like it's a question of recompiling them. It's just, well, there was one place to get them, and that place has slowly killed them off as they came and went. So it's not like we can emulate early apps of, like, early iOS. And that's a little sad, I think.
Yep. Agreed.
Anyways, toodles.
All right. Bye.